Okay, now let's go to a clean sheet of paper and take a look at the way in which these concepts, these ratios, the tangent of an angle, the cosine of an angle, the sine of an angle, can be used. And let's start by thinking of a simple way in which we might use the tangent of an angle. Now, all of these ideas, all of these ratios find broad applications in not only mathematics, various branches of mathematics, but also in the physical sciences and so on and so forth. And we also use them in day-to-day activities, in architecture and in all sorts of ways. And let's just consider one possible application, a very straightforward one, and we'll consider the use of the tangent. Now suppose that we have a flat piece of land here. That wobbly line of mine is supposed to represent a flat piece of land, and an enormous wall. Let's suppose in fact that we're prisoners, and what we need to do is we need to scale this prison wall. Here's the wall here. Now the problem is we don't know how tall the wall is, and we need to know how tall the wall is because we need to know how many sheets we need to tie together. Once we get on top of the wall, which we've got a secret plan for doing, we have to drop some knotted sheets down to the other side like this. I'll draw them in red here, and we tie that one, and then we have the next one, which let's suppose is a blue sheet, and then we tie it to another one, and let's suppose that other one is a green sheet. Anyway, there are three there, but we don't know actually how many sheets we're going to need. What we have to do is to determine the height of the wall, and let's call that height H. Now, how are we going to do that? Now, we're not able to put anything up against the wall because this wall is very high. We can't put a ruler up against it. We can't put even a huge stick up against it and then bring the stick down and measure the stick bit by bit. What are we to do? Well, suppose this is the recreation area, where as prisoners we're allowed out every once in a while to get our daily exercise. And here's a stick prisoner getting his daily exercise. Well, here's one thing that he might do. Let's suppose that he is able to do this. He is able to look along the wall to a point there, which we'll say he can measure. Let's suppose that that is 5 feet. We'll work in feet between there and there. And then let's suppose he looks up at the top of the wall. Ta-dump, like that. And let's suppose that he has a piece of card, or something like a piece of card, that he is able to hold up to his face like this. And suppose he draws that line there, the line looking along there, and the line looking up against the wall. And then he just drops a vertical between the two of them. So he's got a triangle on this piece of paper. Now let's suppose he knows where his eye was at the time he drew this. So in other words, he knows the distance from the wall. Let me just draw those a little bit longer. He knows the distance from his eye to the wall, and let us suppose that that distance was 200 feet. Now, what does he have on this card? Well, because of the invariance under scaling up of tangent and sine and cosine, he has this. He has the height of the wall less 5 feet, that is, this part of the height of the wall is that part of the triangle here. That's h minus 5 feet, ft. And he knows this side of this triangle is 200 feet. And moreover, what else does he know? Well, he knows this angle here. And let us suppose that this angle here is some number, we'll call it a degrees. Now, when I say a degrees, you'll probably know that angles are measured in degrees, and it's an angle between two lines. Let's suppose this is the key line, and we move this all the way around, so we have this angle, and then when we move it to there with this angle and so on, when it's straight up, that is a right angle, that's called 90 degrees. We go all the way around here, the angle all the way around there is 180 degrees, and two of those make a right around the circle, and 2 times 180 is 360 degrees. So 360 degrees, and we know this angle is A, because what does he have to do? Well, he's got it on this piece of paper here. You see this triangle here? He's just drawn it. Now, there are two ways that he could figure out from this piece of paper and the drawing that he has on it of this triangle. Let me reproduce it again. There are two ways that he can work out what this height, what the height of the wall happens to be. Number one, he can simply measure the angle, and then he can find out what the tangent of that angle is. He knows a degrees, so what is tan a degrees? Let's suppose tan a degrees, remember, it's equal to the ratio of the height of this line to the length of that line. And let's suppose he looks up on what we call tangent tables, or we can find it out on a calculator. They store this information, what the given a degrees, what tangent of a happens to be. And let's suppose that he finds out by looking up in tables that tangent of this angle A, whatever A happens to be, is 0.4. Well, we know that the tan of A is equal to h minus 5 feet over 200 feet. Now what can we do? Well, let's multiply both sides of this bit, this equation here, this equality, by 200 feet. And then we have 0.4 times 200 feet. What's 0.4 times 200 feet? Well, it is 80 feet. So on this side now we have 80 feet, and what's h minus 5 feet over 200 feet multiplied by 200 feet? Well, it's simply h minus 5 feet. Add 5 feet to both sides. What do we have? We have 85 feet here. That's 80 feet plus 5 feet is equal to h minus 5 feet plus 5 feet, which equals h. So h, the height of the wall, is 85 feet. Simple. Now, he didn't even look up tangent tables in actual fact, because what he could do with this, given this triangle here, and we'll say this is a degrees, all he needs to do is to take out a ruler, and he knows, because that's the way he drew this line, he dropped a vertical. He knows that this is a right angle. All he needs to do on the piece of paper is to measure this side. Let's call it OPP for opposite. And then he measures this side as it appears on his paper. And we'll call that adjacent ADJ. And he knows those two lengths, and then he can just work out the tangent, because it's the tangent is what he measures here divided by what he measures on his piece of paper here. And using the same reasoning as we go through here, again he'll come out with this answer that the height of the wall is 85 feet, and that is a pretty tall wall.